Hi, my name is Richard. This video is an introduction to computer programming, specifically in the Dart language. In time, we will hopefully be able to review enough of Dart in order to get up and running and programming on your own. But for now, we're going to have to start from the very beginning. In fact, I'm going to assume that you have no previous programming experience, but I will have to assume that you at least know how to use a computer, browse the web, look at videos. At least I'm hoping that's what you're doing right now, and just have some basic familiarity. I'm going to also assume that you're roughly about 12 years or older because I think that's around the age, I could be wrong, just my opinion, but that's around the age when I think it's probably easiest to learn how to program a computer. So let's get started. Let's go to dartpad.dartlang.org. Any browser would be perfectly fine. And when we go there, you will find yourself at a page like this. It's going to have some name right here. It's going to say Dart HTML CSS. We're going to ignore the HTML and CSS, and we're going to ignore the HTML output. You see these curly brackets right here, the green ones? I'm going to delete everything in between and just write print hello world exclamation points. And I'm going to put a semicolon here. Hit run, and it says hello world. And that is our first program. Okay? Let's back up a little bit here, though. I'm really a big fan of terms and concepts. And because we're just learning, we do have to learn some terminology or new words. If you're not really interested in ideas and concepts behind programming, feel free just to jump over to the next video. This may bore you, but if you really are new to programming, it still might be a little bit helpful. Okay, so I'll try to be as precise as necessary, as possible. Okay, right here, what is this right here? Okay, these are English words, right? But this is not English, correct? This basically is Dart, and this is what we call the source code, the stuff you type in the computer language, and this is called the output. What happens? When I hit run, the source code gets sent over to the internet. Oh, by the way, another requirement, you do need internet connectivity in order to use the DartPad. Okay, and we'll discuss what the DartPad is in the future. But for now, we get the source code, it gets sent over to the internet, over to the Google computers, their servers. It gets changed into a different language called JavaScript. It gets sent back into this particular browser, and it gets changed into something called machine code, and it gives us the output. All right, so I went through quite a few things, and so we'll talk about that as this video goes by. Let me just start off also by saying Dart is a high-level, interpreted, strong, and optionally typed programming language. Now let's understand a few ideas. Just again, the basics of programming. Let's talk about high level and interpreted. We'll talk about strong and optionally typed in a little bit later. I hope you know what programming language is, okay? So when we talk about high and low level languages themselves, basically hang on one second. A high level is a language is basically an easier language. Many times, I think we can say that safely. A language that does more for you, but there's a greater level of abstraction. Now, what's an abstraction? You'll hear this a lot in computer terminology. Abstraction is a way of simplifying something by hiding the details in processes. Now, let's just say, for example, you want to eat a chicken. All right, you go to the store, you buy a chicken, it's fully cooked. You pay for it, you sit down, and you start eating, right? That is a form of abstraction because what we are missing is you're not actually raising the chicken, feeding it, then you slaughter it, you break its neck, or you club it on the head or whatever, and you start plucking the feathers out, and then you start cutting the bones out, and you're draining the blood out, and cleaning out. You're not doing all of that. So by simplifying the process, you are abstracting out the process of butchering the chicken. I'm not sure what it's called these days, but killing the chicken before you eat it. All right, so there's some benefits to that, right? You don't have to get your hands dirty, and you don't have to break the chicken's neck or anything like that. And so it's nice and easier, and that's what languages, high-level languages do. The problem behind this is that you don't have as much control. You don't know how humanely the chicken was killed, or if they plucked the feathers while it was still alive, or something like that. Okay, so that's just the idea behind these languages. The major difference between, by the way, if you're a vegetarian, I'm sorry, but I think you'll understand the analogy. And if you do like chicken, I hope you still like chicken. Okay, sorry about that, but that's the only the example I could come up with. The biggest thing about high level and low level languages is, in my opinion, it's probably something called garbage collection. And again, these are just terms you'll hear, and I just want you to be familiar with them when you hear these words. A garbage collection is a system which manages how memory is used. So in low-level languages, you have to actually tell the computer, where is the memory, give me memory, take memory back, and it's very, very, I guess, tedious. It's kind of like butchering the chicken. Again, sorry, but it's kind of like that. It's very tedious. You don't want to have to do it constantly. Garbage collection really simplifies your life a lot. All right, so that's the difference between a high level, I hope that makes sense, and low level. High level, the computer languages, and this is a relative thing, computer language do a lot for you. The low level, you do it all yourself. And the price to pay for all that low level, the do it yourself, is generally speed. The faster, the lower the level of the language, the faster the program will actually run. Dart is actually quite fast, but at the same time, it is high level also. Now we're going to talk about interpreted. So there are two other types of languages. It's kind of along the same lines though, compiled and interpreted. Generally speaking, the lower level languages are compiled. The higher level languages with more abstraction are interpreted. Now, just keep this in mind that I'm talking from a beginner's point of view, okay? Specifically a beginner programmer point of view. It's not a deep technical review. So if you go through the internet and you learn about some of these things, what I say is not completely and utterly 100% accurate, and I'm going to mention this, it's going to be close enough for our practical purposes themselves. So a compiled language, you get the source code, you translate it into a binary prior to actually running the program. So, if you have a Windows operating system and you have a .exe file and you double click it and you install things onto your computer, that is called a binary. There is no source code in that. You just get a simple binary. The source code is what Microsoft has or some other company has. They send it through a compiler and they translate it or they change it into a different program so you can actually run. And that compiler, that program, is called a compiler. So source code, throw it into a compiler, it changes it into a binary, and the binary, one example of a binary is the exe, is what the computer actually reads and runs. And the time it takes to change the source code into the binary, that's what we call compile time. When the compiler is actually in the process of changing the source code into a binary. Examples of compiled languages, C, C++, and assembly. And these are also what we consider low-level languages because you have a lot more control over what you do. And these are fast languages, but at the same time, they are compiled. So you have to get the source code and change it. Dart is interpreted. It is not a compiled language. Therefore, we're not going to actually be creating like .exe files themselves with Dart. So just keep that in mind. What Dart actually is, it's an interpreted language. And basically, with interpreted languages, you get the source code and it's translated to machine code when the program is run. So at runtime. So there's no compile time. The compile time is the runtime. Remember what I mentioned before? I said this source code gets sent to the Google servers. It translates it. And there's a whole lot of processes. It gets translated to JavaScript to machine language. Well, that's what happens at runtime. So there's no compiling, and then you run a binary or any other type of program. You run it straight from the source code. Interpreted languages use a virtual machine or a VM. It can also be called a translator, an interpreter, or a runtime environment. Now again, there are actually a little bit of differences between all of these, but at the same time, most of the time we use them synonymously. We use them as if they are the same exact thing. And for practical purposes, whenever people talk about a translator, interpreter, right, that's pretty much the same thing. Okay, so that's what you could just keep in mind. Technically, there may be a difference. I'm talking about just for our purposes right now. Interpreted examples, JavaScript, Python, and Dart. Java is one of those hybrids. It has both a compiled and interpreted type of component to it. Not that important, just to keep that in mind. Dart VM and JavaScript VM, they use a technique called JIT, meaning just-in-time compilation. Again, we don't need to know too much details, but just the concepts, because as you learn more about Dart and other languages, you may get these words, and I just want to throw them out there so you're at least familiar with them. What JIT, or just-in-time compilation, is, it's a technique to optimize code on the fly. In other words, while you're running it, as the process runs more and more, it becomes faster and faster. Optimizing a code simply means make the code run faster. So do you remember sometimes if you click a button, the computer kind of stalls and finally something happens? That stalling period is what we call a latency. So it's a little bit of a latency or a lag. It doesn't respond very quickly. Optimization is when you minimize on there. So instead of waiting 5 seconds for something to happen, it happens immediately afterwards. You click it and it immediately goes through. Okay, so that's just another word that we would like to know and keep in mind. So I think that's it for this. Actually, one last thing I did want to talk about. It's the differences. So compiled versus interpreted. What's the difference? Why is there a difference? Generally speaking, like I mentioned, compiled languages are faster, but they're targeted to a specific platform. You notice that if you get a .exe file, right, you can't just run it on a Mac OS, or I usually use Fedora or Ubuntu. You can't run it on a Linux distribution either. You have to compile it to a specific platform, a specific environment. All right. The interpreteds, as long as you can run the VM in a different environment. So if I run the Dart VM in Windows or Mac or any version of Linux itself, then I can run the code itself. And so interpreted is slower, especially at first, because remember, we talked about JIT. So it optimizes later on, and it runs faster the more you run it, within reason. But it's targeted to the VM. So wherever you run the VM, you can actually run the code. Unlike a compiled language, you can only run it in that specific platform. And therefore, interpreted languages are more portable. And that's why Dart is important, because it's portable, because it can run in any browser itself that has the Dart VM. If it doesn't have a Dart VM, it can be translated. Remember, I said this gets sent over to the Google servers. It gets translated to JavaScript. JavaScript can run here in the browser itself. Finally, I think I left one piece of terminology out. I mentioned before machine code. What machine code basically is, the language of computers. So computers actually see things in terms of ones and zeros. Why? Well, if you have a transistor or a circuit, not really a transistor, I think it's more of a circuit, you have electricity traveling from one area to the other. It either travels across a circuit or it does not travel across the circuit. And that's why it's a 1 or a 0. And that's all processors really understand. And so machine code is a bunch of ones and zeros. And so what you're getting is you get JavaScript to run in the VM, and it gets changed into machine code, and therefore your browser is able to actually run it. That's a gross oversimplification of what the process is, but that's when people talk about machine code, they're talking about nothing that you're actually coding in. All they're talking about is what the computer actually sees, that the VM abstracts away, right? So it hides the details away by making it nice and simple for us, or at least the code. All right, I hope this was helpful for you. Let's keep moving on. The next video is going to be a lot more practical in terms of actually learning to program, though, okay? Thank you very much.